Next example. So here again a automata is given to you and we need to convert this automata to a regular expression form, right? So there are three states, q1, q2, q3, among which q1 and q2 are final state, q3 is a non-final state, and q1 is the initial state, right? So again we write the equation for all these three states by considering the invert transitions and adding epsilon to the initial state. Okay, so we get an equation for q1 as q1 0, because to reach q1 you can read a 0 from q1 and reach q1 only, right? This is one way, and the another way is as it is the initial state, so you can directly reach q1, so we add epsilon over here, right? Then for q2 there are two invert transition, one is from q1 on 1 and another is from q2 on 1. So we get a equation for q2 as q2 equals to q1 1 and q2 1. So we add them, right? So this is union. So either to reach q2, either you can get a 1 from q1 or you can get a 1 from q2. Okay, so these are the two options to reach q2. Last equation for q3. So there are three transitions that are invert toward q3, which is 1 from q2 on 0 and 2 from q2 on 0 and from q3 on 0 and 1, right? So we get an equation for q3 as q3 is equals to q2 0 plus q3 0 plus q3 1. So you can write it in this form as q3 0 plus 1. Okay, so these are the three equations which is obtained for the given finite automata. Now you need to obtain expression in terms of 0 and 1 for the final states. So here we have two final states, so we need to obtain for both. Okay, so let us see how we can solve this. So to get equation in terms of q2, here we need q1 and q2, here we need q1 only, so we can directly start from q1, right? So you can see that it is of the form r equals to q plus rp. So you can directly apply Arden's theorem on this equation, that the result will be qp star. So here q is epsilon and p is 0, so the solution to this equation will be q1 equals to epsilon dot 0 star, which is nothing but 0 star only, right? So we have obtained an equation for q1, right? That is 0 star. Now we want equation for q2, because q2 is a final state. So now in q2 you have value for q1, so you can put this value in q1 and the equation q2 becomes q2 is equals to q1 plus q1 1 plus q2 1. This was the original equation. Here we have put 0 star in place of q1, so we get a equation as 0 star 1 plus q2 1. Again you can see that it is of the form q2 is equals to, like suppose this is r, so this is r equals to q plus rp, right? This is of the form of the Arden's theorem, so we can apply Arden's theorem to it, and the solution to this is r equals to qp star. So our q is 0 star 1 and p is 1, so the solution to q2 becomes 0 star 1 the then again 1 the whole star, right? So it becomes 0 star 1 1 star. Okay, this is according to Arden's theorem. Now you can see that we have obtained equations in terms of 0 and 1 for both q1 and q2, and we need to find equation only for the final state. It is not necessary to obtain for the non-final states, right? So these two equations are obtained, so we are not required to obtain equation for q3, right? If there is q3 in either q1 or q2, in that case we would have to we would have required to found value of q3, right? So we'll skip that, right? So because q1 and q2 are the only final states, now there are two final states, so we need to consider union of these two states, right? So either this would be accepted or this would be accepted. The regular expression which is at q1, either this would be accepted, or the regular expression which is at q2, that would be accepted, right? So we need to consider union of these two regular expression. Thus we get q1 union q2, which is nothing but 0 star plus 0 star 1 1 star, right? So either 0 star will be accepted or this equation will be accepted. Okay, so again if you look at this, the 0 star is common, so you can get 0 star in bracket, you will have epsilon plus 1 1 star, and there is property that is uh, that says that epsilon plus 1 1 star is nothing but 1 star, right? Epsilon plus r star is nothing but r star. So you can replace this complete thing with r star, and r over here is 1, right? So it becomes 0 star 1 star. So 0 star 1 star will be accepted by this automata. So the regular expression for this automata is 0 star 1 star. Okay, now here we have considered union because there were multiple final states. If there was a single final state, we would have considered a single equation as we did in the previous example, right? So this is about the regular expression wherein there are multiple final states. Okay.